All right, well, let's just jump right in. Yeah. So, I'm CEO of Devici, and a little bit of background about me. I've been in cybersecurity for 26 years at this point, so I feel like I've almost seen everything and done everything, as well as I feel like things are kind of making a way back around over time. Had a chance to spend 11 years at Cisco and helped to build Cisco's internal security program. From there, I started Security Journey, my first startup, which we sold in May 2022, and I retired for 2 weeks. I don't recommend anybody do that. It's a terrible experience. There's nothing to do. So then I started another company shortly after that, and that's Devici. So when we think about, we're going to talk in great depth here about what I call secure and private by design and default. But I want to stop for a second and think about, over the last number of decades, how far we've come or how little we've come in solving the security and privacy challenges that we have. And so I attribute it to perhaps building a Gothic cathedral. So imagine we built this Gothic cathedral and there's holes in the walls, the roof leaks. It's got all kinds of problems driven back to the architecture of it as to how it was built. And it also makes me reflect on where we've been over the last number of decades when I think about the OWASP Top 10, for example. So the first OWASP Top 10 came out, I think, around 2003. They did a version a couple of years ago, 2021. They're doing a new one this year. And the challenge I've always had with that is things just aren't changing that much over time. We're still dealing with a lot of the same problems that we've had for a number of decades. And so I think we've got an opportunity in front of us with secure and private by design and default, and that's what I want to talk to you about today. So I'm going to introduce the concept from my perspective based on what I've learned about it, and then I'm going to conclude with what I'm calling the sum of my frustrations with this topic. From there, we'll talk about some tactics for designing software where you consider security and privacy properly. A collection of things that I call design decisions. We have the use of data flow diagrams, a series of patterns that can be applied to build things better, and then also how we can integrate threat modeling into this to what I'm calling checking the work. And then from there, we'll talk about how do we measure the movement of these types of changes, because at the end of the day, nobody in this room is here to do this one time. It's about how are we going to do this over a bigger organization, how are we going to do this with 100 apps or 20 products, how are we going to measure how this movement's going to happen. So I'll also leave some time for questions and answers as we go. So let's start out by just coming up with a definition that we can use for this idea of secure and private by design and default. So I borrowed this definition, at least parts of it, from the good folks at CISA that provided this definition in their Secure by Design guide. But I made a few tweaks, I changed a few things. I added this idea of art and science. And so I really do think that building things where we consider security and privacy properly, there is a science to it. There is a way that we can use repeatable processes and whatnot to build things a certain way. But there's also some art form to it. We have the ability to do some innovative things when we build things, when we design things. So it's really about the art and science of prioritizing both security and privacy from the time we start thinking about something until we end of life it. But check out that word in the middle there, reasonably. I got that from the CISA, that was in CISA's definition. Reasonably. And like I said, I've been in security for 26 years. I've spent a lot of years being unreasonable when I think back across the history of my career. I started in security in a time where we just expected people to do what we said because we were from security. That's not really reasonable. And so I think that's an important concept that we need to include in any of these things that we try to do into the future is how do we do this from a reasonable perspective? But also, secure and private by design and default is also a philosophy. This is not I'm not going to give you a set of requirements here that you can then go and try to implement. It's a philosophy about how we're going to design things better. It's also a journey of outcomes. This is not something we can implement in the next 6 months and say, well, we got that whole thing figured out, we're good now. This is something that, especially when you have existing products, existing applications, This is a multi-year approach to how we're going to improve the things that we build. So what do customers want versus what do customers need? At the end of the day, personal, individual customers just want us to protect their data. That's it. And really, corporate companies they just want us to protect the data attached to the company. But what do they need, though? Well, they need secure and private out of the box. They need this idea of secure by default and private by default. The things that we provide, the solutions that we provide should meet that criteria. We need automation, configuration, friendliness. If somebody's going to buy 100 of the thing that you make, they shouldn't have to touch 100 of them to make it secure and private. They should be able to do it in an automated fashion. It should be self-updating without user intervention. I wish my phone was self-updating without user intervention. I have an iPhone. It's supposed to they had some new feature that said it was going to update itself. Every time I have to say yes, I have to approve it or whatever. Like, I just want it to update when I'm sleeping. And then the last one, hardened and protects itself. So we have to build things that don't require applying a set of steps. Well, if you want it to be secure, you can do these things using this guide. No, we got to lock these things down out of the box, whatever it is that we're making. So what are the core tenets then? Holistic security and privacy approach. We want security and privacy baked into everything, every step of the way, everything that we're considering in what we're building. We have to recognize that these are business priorities, they're not technical features. We don't build security features. We make security and privacy a priority in the things that we build. That's a mindset that I've seen the beginnings of the shift happen throughout my career, and it's gotten a lot better from where it used to be. But we're still got more ways to go. We want to think about protecting existing things versus adding new features. There's always that tension between product management and engineering and the security team. Product management says, let's build the new coolest thing that everybody's going to love. The engineering team says, well, we're going to build whatever everybody can agree to. But the security team needs to continue pushing for, let's make the things that we have more secure and better. Once again, secure and private by default is the state that we need to be in there. Now, it's easy to just say these are the things that we have to do, but there's a set of forgotten challenges that come along with this. And we can't lose our focus on this. We have existing timelines for products. We can't just say we're going to stop doing anything new until we solve our security and privacy challenges. We have to factor that in against keeping our customers, because if all we do is focus on security and privacy, yes, we may have the most secure and private products on the market, but we may not have any customers anymore because we haven't done anything innovative in years, perhaps. Retroactivity, another challenge with this is, like I said, this is a multi-year approach. We're going to have a bunch of things that we built over the last years before we figured this idea out. We're going to have to retroactively go back and improve those things over time. It's not going to be instant. And then purpose. We have to have some amount of purpose to what we're doing here. So here's what I like to think of as an unpopular, but I believe true opinion. You may think differently than I do on this, but this is after studying this area and all the attention that we've had on secure by design. Technology and government regulations are pushing this idea of security and privacy by design and default. But I don't think that anything that I've seen written so far tells me how to actually do it. There's no implementation guidance that I've been able to find. And I'll show you, I'll pull the thread on this here for a second, and I'll show you the different things that I looked at to try to see if maybe I was just missing something. But then I'm going to give you my thoughts on how I think we can really implement this. We can make it a reality. So let's start with the secure development lifecycle, okay? The process that we go through to ensure that we apply the right security and privacy controls to all the stuff that we build. I'm a giant secure development lifecycle fan. I love it. I focused for 5 years on it at Cisco. But the question I have for you is, if I follow that process in each and every one of those steps, do I have something that's secure and private by design and default? Guaranteed. I'm getting a couple of head nods, and that's where I concluded on this too. I love the process, I love the repeatability of it, but it doesn't guarantee me secure, doesn't guarantee me private. It gives me some good steps, but I can't just say this is what I have to do. What about secure by design principles? Right? These have been out since the 60s or whatever, when the Salzer and Schroeder paper was originally, I think the 60s. If I build something that adheres to these principles, is that secure and private by design and default? These are good things. I don't have a problem with doing it, but I don't think that is a criteria that we can use to say something meets this new standard that I'm talking about here. Whether it's defense in depth, where we're creating multiple layers of security, and once again, I love this idea. I think it's something we have to do, all the way down to, are we practicing least privilege, where we're ensuring that we're not using accounts and service accounts and things that have maximum root privilege or admin or domain admin or whatever. Are we minimizing our footprint? Are we failing securely so that if the system does fail, it fails closed and not open? All of these are good things, but I don't think that gets us to secure and private by design and default either. Okay, what about the privacy by design principles? These are the ones, like, I've spent most of my career focused on security. So privacy is something that's new to me, and it's something that I've been learning a lot about as I go. But as I started to unpack these and say, okay, proactive, not reactive, preventative, not remedial. Okay, generally good practice. I don't have a problem with it, but I don't know that that gets me where I need to go. Embedding privacy into the design. Yeah, once again, that's something we want people to be thinking about privacy, but that doesn't give me a private solution. That just means that I'm focused on trying to understand what might entail in a private solution. Visibility and transparency, respect for user privacy. Like, these are once again all good things, but I don't think they get me where I need to go. And so I think we've got a different direction. And then how about the guide from CISA? Once again, I mentioned it once already. I'm a big fan of it. I think it's a good document. I think it was well written, has lots of good information in it, but I don't think it's an implementation guide. I think it's more of a collection of facts that give me lots of good facts and things that I can use, but not something that I can hand to somebody and say, developers, can you build this new system using this secure by design document from CISA? So I'm not hating on it. I'm just saying I think there's something else that we need to do. And so that brings me, though, to the sum of my frustrations on this journey that I've been on. The classic principles they miss the mark in that putting them all together with SDL still doesn't get me to where I need to go. The guide from CISA is about facts, not about implementation. And we need some type of glue in between these two things, and that's what I'm referring to as secure and private by design and default. So I couldn't just get up here and talk about how things are broken and don't work. I had to give you some type of a solution as part of what I'm bringing to the table. And that's how I've broken this down in this high-level flow for how I think we can apply this concept to the things that you're building. So it starts by understanding a collection of design decisions that you can consider when you're building something new, or you can retroactively apply them to something you've already done. Data flow diagram is for me the core of how I capture a design. I like the visual nature of data flow diagrams. You could convince me that it's better for you to write paragraphs of text to describe the things. I'm not gonna argue with you on that. For me, data flow diagrams just make sense. And then we've got a series of patterns for how do we apply these secure and private controls to this thing that we're building. Why reinvent the wheel? Why do something creative when we can take something that's tried and true and battle tested and put it into action? And then the fourth one there is check the work. So we're going to use a fictitious company called Supercar here as our backdrop to test this implementation that I've shared with you. And so I want you to think of Supercar as perhaps the next great ride-sharing service with the coolest logo that ChatGPT could build in one prompt. It's got a couple of different services: an account, driver, and schedule service, as you would imagine, managing your account, interacting with the driver, and scheduling services. Think of this as just as plain of an application as we can imagine. It's microservices, it's REST API, it has a back-end database, so pretty simple. But I wanted to give this as a backdrop for walking our way through this process I'm going to describe. So let's get into these design decisions. And once again, like I said, this could be something that we're applying when we start and we're able to create something from scratch, or when we're retroactively trying to improve something that we've already built. And so it begins with this idea of a security and privacy enforcing stack. Stack just meaning what are all the technology solutions and all the decisions we need to make about what we're building. For me, it's about the architectural components that are going to give us the best chance to have a solid approach to security and privacy. And so it begins by choosing a language. And so the recommendation, and like I said, these decisions, these patterns, all of these things are coming from multiple sources that I already talked about. I'm not inventing all these things myself. I'm just packaging them up a little bit differently. But choosing a memory-safe language, that came directly from the CISA guide. What's the advantage of a memory-safe language? Well, things like Go and Rust and even Java, they're memory-safe, meaning that the memory management is taken away from you as a developer. The language, the framework takes care of the memory management for you. So it is almost impossible to introduce a remote code execution or a buffer overflow in one of those languages. I won't say it's impossible because I'm never going to do that because somebody will figure out a way to do it. But in general, it abstracts you away from the need to manage memory and make, as a developer, where you can make mistakes that could result in buffer overflows being possible. So then also on the framework side, if you're building a web application, we have React, we have Angular, we have Vue, we have all of these front-end frameworks. And over the last number of years, they have really taken a much tighter approach to security, to the point where they're doing things to sanitize data in the frameworks themselves. And so the second part of that is ensuring that whatever we're going to build on top of, we're using a modern JavaScript framework that has applied these concepts of security into the framework itself. On the database side, how are we going to protect privacy at the database tier of the architecture? Or how are we going? What are we going to use for encryption? What algorithms are we going to use? Are we going to encrypt at the table level, at the database level, at the row level? Like what level of encryption are we going to go to here to protect that data? A lot of that's going to be driven by what the data is, but there are some things we can do from an encryption perspective at different layers. And then on the hardware and cloud side, starting with cloud, when I think about what security services I can use from AWS, from Azure, from GCP, they all have a standard set of security services that they kind of give different names to, but they've really moved security forward from a default stance in those cloud environments. And so also like with hardware, if you're building something that uses hardware, use whatever hardware protections are available, like memory protection, for example, where the CPU can block out a section of memory that's non-executable and it'll never execute anything that's in that structure. Use those things to your advantage, but also on the cloud side where you're using services that are standard part of the cloud stack to better secure the things that you have. But really, the ceiling of whatever you're building from a security and privacy perspective is really tied to how well you do with the stack here. So how about a secure private user experience as our second decision? And really that decision is how are we going to adopt security and privacy into the user experience portion? And UX people are the excellent folks who take a user interface and a design and they point out all the ways that it needs to change to make it make sense to us as humans when we're processing. My design decision here, though, is how am I going to take those things and include them, the security and privacy angle, in the user experience itself? Because there's some different things that they can be looking at. When we think from a security perspective, simple and non-disruptive user flows. That's a general user experience control, but it's also something that can apply to security features and it can apply to the security of features. How are we going to balance security versus usability with risk level? If my bank is building a new feature that could allow somebody to transfer all of my money out of my account, I don't want that to be super usable. That should be pretty difficult to use and have a lot of checks and balances and things that go into it. But if you're just talking about some simple operation that doesn't need 27 layers of protection, that's a user experience input can help us there. Making sure things are consistent, clear and helpful error messages. I mean, that's something that lots of security segments have struggled with in the past. When you get an error message and you're like, I don't really know what that even means. I know Windows in the days of old had all these classic error messages that you didn't really know what was the problem. The message didn't really help you. And so having error messages that are clear and helpful is a positive step. Then on the privacy side, how are we going to transparently share with the user how we're using their data at the user experience layer? How are we going to ensure that people understand, hey, we are storing this data and here's how we're protecting it and here's how we're using it as part of the interface and the experience. And then, you've got control over personal corporate data, avoiding consent fatigue. I mean, how many times do we have to click these cookie banners now? Like, does it even mean anything anywhere? I'm sure there's somebody somewhere who's clicking them and reading them all and figuring that out. And then a balance between functionality and privacy protection. So the third design decision is protecting PII and customer data. So focusing back on how are we going to have a privacy policy and a strategy that really helps us to protect that PII we talked about earlier and the customer data side. When we think about minimization, how are we going to minimize the things that we're storing? Because maybe if we don't need it, why are we storing it in a database? If we don't need that data for a business purpose, let's just not even store it at all. Encryption, we talked about how can we anonymize information if we're going to pull statistics from our application. Do we really need to be able to tie them back to an individual user? Or do we just care about the broad spectrum of all of the different statistics? Doesn't matter who generated them. And then de-identification. Is there a way that we can store data in such a way that we can take away the connection between the user and still have that data be useful and actionable within the system? But the thing that I see about data in general is you can really only protect those things that you understand. So my fourth one is lock it down. So how are we going to lock down the solution as much as possible and still meet customer requirements? And so I mentioned this earlier, I want secure by default without hardening. I don't want to have to harden any type of solution. I want to also limit the attack surface as part of locking it down. So when I'm analyzing and I'm looking at an overall system, I'm thinking about what are all the interfaces that an attacker could use and regular users to get in. Do we need all of those interfaces, or can we minimize those down to some smaller set? One of the disagreements I have with the CISA guide is they have this concept of loosening, where they prescribe you should build a solution, you should ship it secure by default, but you should give somebody directions on how to loosen it, how to reverse the security controls if they have a business need to do it. And I've struggled to find a scenario where I think that makes sense. I just can't get there. I think we've been fighting for all these decades to get to the point where things are secure by default, and now we're going to give people an out where they can somehow loosen it if they want to. I'm like, no, let's just build these things secure, and this is just how the feature works now. And we may have to deprecate older versions of it for compatibility or whatever, but let's not do loosening. And that's the deprecate unsafe legacy features. But the fewer interfaces we have, the better we protect them, the less attack surface that an attacker has to work with. About responsibly using open source is a design decision we have to make. What's our strategy for open source and how we're going to enforce it? And I realize a number of these things, like SCA, I don't even want to talk about anymore because it's been said so many times, but it is a core component of how we do our approach to open source. But I think it starts with that choice of, are we going to just let developers load any package they want, or are we going to enforce some type of proxy control where the security team has pre-selected some number of packages that are acceptable and then there's an exception process through? It's part of our strategy. What's our criteria for using open source? Do we allow developers to use things that are less than a certain age, have a small number of total builds or releases, a small number of people that are behind them? I mean, there was a popular story in the news about this XZ thing with some other agent becoming part of the core team and then adding some code that didn't work out so well for the people that it was added to. Then also challenge us to say, nobody thinks about privacy from an open source perspective. Nobody thinks about if an open source component is something that protects privacy, is neutral, or is terrible for privacy. And so I want to challenge us to start thinking about open source from a privacy perspective as well, because we have so much open source integrated into the things that we're building. Sixth one, detect and mitigate issues in code. So we have code reviews, we have tools that do this for us, but we have secure coding standards. How come we don't have privacy coding standards? I've never seen a privacy coding standard yet. Maybe it's just I run in different circles, I don't know. But I haven't seen anybody take that same concept. Everybody has a secure coding guide that tells you what you should and shouldn't do. Let's add privacy to it. Same thing from a code review perspective. Do we have privacy code reviews that are just looking at the data that's being added and put into place? One of the cool things is I'm seeing static application security testing tools. They've done security forever, but I'm starting to see some tools that are focused on privacy. scanning for data, trying to figure out how data is moving around. I think that's a positive step forward. So it's a check and balance. Seventh one is dealing with vulnerabilities. You know, what's our product vulnerability management perspective? What are we going to do with SBOMs? Like, I think SBOMs are a great thing from a transparency perspective, being able to understand what are the component pieces of the things that you're buying and using. I think the challenge with SBOMs has been, there's been all this noise about it, but nobody really knew how to put it into action and to really get any results out of it. But I think that'll catch up. But I think SBOMs for transparency and being able to know what are the components of the things that you're buying is still a strong thing. It's something you have to do. It has to be a design decision. So when we think about how these design decisions come together in our supercar example here, so from the stack perspective with supercar, we're going to use Go, we're going to use React, we're going to build this on top of AWS using all their security goodies. We think about the user experience. Well, we can add some steps for security and privacy UX review into the process for how we build things. From a data perspective, we got to inventory the data that supercar is keeping and then have a plan for how we're going to protect it. Locking it down, let's go least amount of mechanism, and then a series of tools responsibly using open source. There's a tool called Go Vuln Check, which is effectively a software composition analysis open source tool for Go. There's GoSec, which is a security scanner. We'll have to do something commercial for privacy. And then dealing with vulnerabilities, we've got product security incident response, we've got SBOM for transparency, and then security at email aliases for communication. So I just wanted to, so once again, this is a kind of a real world example of how those decisions come together. So here's the supercar architecture. Here's a simple approach to what supercar looks like. And so on the outside of the trust boundary, the dotted line, you've got riders, drivers, and attackers that are using browsers and mobile apps to integrate or to communicate through our API gateway to reach those other services. And then each of those services is backed by its own database. We've got a content delivery network included inside of this architecture as well. And then I also love to show a non-person entity. I did some studying of Zero Trust last year, and I was not thinking about NPEs as entities or external entities we needed to be thinking about in the systems, but if you think about how the modern internet works and the modern world of applications, there's a lot of non-person entities that are consuming APIs, publishing information into other APIs. There's a lot of that happening behind the scenes here, and so it's good to keep that in the focus when we're thinking about what are the threats that could exist here. So then let's think about assessing and applying some patterns. So when I think about security and privacy patterns, there's a few different things that kind of describe them. So there's this idea that they have to be reusable. So we want something that we don't want to have to rebuild this component. We want something that can be reused over time in different places. It should be a better practice. So it should be better than building something from scratch. And then it's also very similar to a blueprint. Being able to attach all of these things together can save a lot of time. And so you'll hear this concept of guardrails, paved roads, and patterns. And so when I think about a guardrail is building our security program in such a way that we identify both sides of the road and we give developers freedom to create as long as they don't go off the road and bounce into the guardrail. But when I think about paved roads, I think paved roads is really the concept that really fits closer with patterns. So the idea with paved roads is let's build a component that a developer can pick up and use that's far easier than if they had to try to create something from scratch themselves. Let's give them a reusable component that they'll go, yeah, I just integrated that because it just made my life easier. So we start with base patterns. So if we're going to apply these patterns to the supercar architecture, there's a few base things that I thought they weren't worth calling out on their own, but they were worth calling out as just base things that we want to do. So it starts with HTTPS only, TLS encryption, kind of from a baseline perspective. We're going to encrypt everything across all data flows, even inside of the architecture. Everything should be TLS encrypted and HTTPS through the front side. Security headers are something that's a base pattern as well. Seems like they should be table stakes at this point, but anybody who's ever configured a content security policy and gotten it to work in production for more than a week can attest to the fact that It's not super complex, and I love the fact that I'm seeing a couple of people laughing right now because that means they've done it before and they felt that pain. It's not an easy thing to do because you finally get it working and then it just stops working for no reason. Oh, why can't we access that? I don't know. But it is a crucial thing because it does help to control. It is an important building block that we have to have implemented. And the last one is single sign-on. And I throw single sign-on in there just because in this day and age, it seems like we shouldn't have any usernames and passwords like for a single system. It seems like everything should be single sign-on. And part of the reason I've landed on that conclusion is single sign-on has become something that's very easy to implement to an application. Like if you're building an application, a SaaS application, for example, and I happen to play in the Amazon, the AWS ecosystem. AWS has this thing called Cognito. Cognito is a service that allows you to enable single sign-on in your application. And it's super easy to integrate. And I know that because the previous company I started, we built our single sign-on from scratch. That was not easy to implement and was actually a bad idea. We didn't really have any other choices in those days, perhaps, but it was a very complicated thing that broke all the time, whereas using another component like single sign-on is something that can save a lot of time. It can make our approach to storing user information better, and our approach to using it as our access mechanism or our authentication identity mechanism. So the first pattern here is authentication and multi-factor. And so we extended those external entities a little bit out to say, there's a couple different things that you can do from a multi-factor perspective. You can, use things like mobile codes, authenticators, and even go as far as to use FIDO keys and stuff as a way to enhance that authentication. And then the other thing that we pointed out in this architecture is that we're funneling all of our authentication decisions through the API gateway here. And that's why we've got that circled in orange just to highlight it. Because we don't want to have to push authentication into each of those microservices. We want to handle it at an earlier layer, once again, just to make it less complex. And so you've got an identity provider, you've got a user database, API gateway is communicating with those. You got multi-factor included inside of that, but that's a strong pattern that you can build an entire collection of applications on top of. Second one is access control and authorization. And so ABAC, attribute-based access control, the concept where instead of just having users, groups, and permissions and privileges and things, we're able to use various attributes to describe things like this user should only be able to connect from this location, they're authenticated, and they're only allowed to access the resource from this time range, right? So we've got just more granular controls that exist within ABAC. But I want to also share an example of this. I do a podcast called Application Security Podcast, and I had a guest on whose name is Mukund Sarma, and he works at Chime. And he was telling me during this interview that Chime has built this authorization engine that allows developers, when they create a new microservice, they have to create like a 10-line JSON file, and that's it. So they can configure authorization for a new microservice in about 5 minutes or less. And it's a powerful example because it's taking this approach of a paved road, but it's giving the developers a security control that they literally have to spend 5 minutes configuring it, and then it's good. Because it's just they can set a set of statements inside the JSON in a standard language as to who should be able to access this, what other services should be able to access it, what are any constraints on it. Perfect example, though, of how we build patterns that make security and privacy easier to do than how we've done it historically. Okay, our third pattern is validation, sanitization, and encoding. So we want to use standard validation, sanitation, and coding libraries. In our example here for Supercar, there's Safe HTML is a Google library for Go for writing things back out to ensure JavaScript doesn't sneak out because some other nefarious input was snuck in to the services. And then we've got on the Go side, you've got a library called Validator that helps you to do that input validation. So the thing about validation, sanitization, and encoding is none of this is something you have to do from scratch in any application with any language these days. There are ways to do these things across every language that's out there. Fourth one is just using secure logging. So a pattern is how do we ensure that each of the microservices, each of the components in the architecture are all feeding back to a SIM solution so that the incident response team has the ability to really know what's happening, what's gone on inside of the architecture when we have an incident. And I did incident response for a number of years in the early days, and can't tell you how many times we came in to investigate someone's breach, someone's compromise, and they had no logging. Zero logging for anything. And it's like there's just nothing, there's nothing we can really do. We don't have any idea what happened because there's no log that helped us. And so that's why this pattern is we want to ensure we've got logging feeding back to a SIM across all of the components in the architecture. Proper password storage and initiation. This one isn't as hard from like a web app perspective. It is challenging when we have like a product that we ship as a metal box, for example. And so this is just about how do we use the identity provider, how do we store things in the user database to ensure that we have that user information properly protected. And the sixth pattern we can apply is data protection, and that's really just how are we doing encryption, like I said earlier, database table, row, like what level are we encrypting, and then the harder part, how are we managing the keys involved in this? How are we ensuring that we don't end up with keys that are stored in the wrong places? How are we using a secrets vault to drive the database encryption process so that keys are rotated at a normal interval without a lot of manual effort happening? And then the last one is just scalability, last pattern that we can apply, and that is, how are we using orchestration like Kubernetes to build the architecture in such a way that it'll scale up and scale down, even if we do find ourselves facing a wicked distributed denial of service attack. Not as big of a problem these days because speeds and feeds have gotten to the point where there's just so much capacity available now. It's really difficult to pull off a denial of service. But still, you have to architect to ensure that simple denial of service can't knock an application offline. So I wanted to point out Clint Gibbler, who does the TLD RSAC, put together this list called Awesome Secure Defaults. So there's all these awesome lists out there. They made an Awesome Secure Defaults list, which they've gone through and made an inventory of many different libraries and whatnot that are a part of various types of security categories, like how do you do headers, doing cryptography, protecting against SSRF attacks, things like that. So just wanted to throw that out as a resource for you to understand, because it is something that you can find a lot of good libraries and references there. As far as checking the work, how does threat modeling come into this now? Actionable threat modeling tips here. These are some of the things that I think you can do to really apply the checking the work steps to it. It comes down to having a functionally diverse team. So what I mean by that is I don't want to do a threat model. I don't want to check this supercar architecture with all just developers. I want some folks from the security team, some privacy representatives, some developers, an architect, some testers, some product managers. I want to have a diverse group of people that will help to ensure that we're bringing the right perspectives. So you can find inspiration for where threats come from Stride LM. Stride's the kind of the oldest threat modeling mnemonic. Others have added lateral movement to the end of it. That's something I've embraced recently. And then you can use various OWASP documents as a set of threats to consider. So OWASP Top 10 for web, for API, for LLMs. There's lots of good threat source data there available. Go beyond the patterns. And the other thing to remember with mitigations are the most important thing when we're doing threat modeling. We come up with a problem. If we don't mitigate properly, we just wasted all this previous time. And so that's something that we want to be a core piece. And then also just want to draw attention, there's another project called Threat Modeling Capabilities that myself and a number of other threat modeling people work together to build a capability model that you can use to understand how you can build a more robust threat modeling program, whether you're a small organization or a large one. kind of some collective wisdom from a lot of different perspectives came together to build that capabilities model. So it's important to understand when we talked about Stride LM before a few times between spoofing and tampering and repudiation and whatnot. Each of these does have a compensating pattern, so the patterns do match up when we think about the threats that we've uncovered. The patterns do match up with the various categories within Stride. So for example, repudiation, where somebody's doing something that we don't have tracking, we don't have traceability on what they've done. Secure logging and strong authentication is the pattern that answers that threat. And so when we go through the threat modeling process, we do have various threats and various compensating patterns. And so if we extend this out to the supercar example that we were working through, here's a collection of different threats. So broken access control, if you look across the OWASP, that's from the OWASP top 10, broken access control just means that it's a threat where developers made some type of mistake in the access control engine that results in people being able to bypass it and access data they shouldn't be able to. Well, the compensating decision or pattern there is access control, a strong access control and authorization approach. Broken authentication, MFA. Logging failure, secure logging. Denial of service, scalability. Server-side request forgery is one of the newest web attacks. It's not new, I mean, it's a few years old now, but this idea where the attacker turns your application into a proxy server facing inbound into your organization. So they find a vulnerability in the web app which allows them to send a request inside the company and then pull some data back from some other type of scan or search they've been able to do. The compensating control there is, we talked about validation, sanitization, and encoding, and the stack as also, and then security misconfigurations, ultimately locking it down is our answer there. And so measuring these types of changes. So somebody asked me earlier about, how do we measure this type of a change, this type of a system that you're talking about, these 4 different categories of design decisions and patterns and data flow diagrams. How do you measure the impact it's having? And so this is my thoughts on, I think, how we could take this and operationalize this inside of an organization. So creating that customized dashboard to be able to track your decisions and patterns, I think it can be as simple as just having the right traceability and tracking to see where these decisions and patterns are being put into place. And I think it's important to know that these same design decisions may not map directly to your organization. You may modify some of them, you may remove some of them. It may be something that you need to customize some for your own organization. And then I think it's as simple as just evaluating that implementation of each decision and pattern with zeros and ones. I don't want to make this overly complicated. I just want to know from all the 7 design decisions, were those things considered and applied? And there's a 0 or a 1 that goes along with it. And then also I'd love to see measurement of the number of threats that each version mitigates each time that we apply this process. What are we mitigating, and then what's the correlation between where we implemented decisions and patterns and the rate of which threats are mitigated there. So I think these are different ways that we can measure this implementation of secure and private by design and default. And so I think, kind of in conclusion here, we can build something better for the future than we've built in the past. We can build that Gothic cathedral that the roof doesn't leak and there aren't giant holes in the wall, right? That represent the various software challenges and problems that have been inherent in the things that we build. I think by applying these concepts of considering the design decisions and having a data flow diagram that you can use to conceptualize the threat modeling process, applying the patterns, and then using the threat modeling process to check the work. I think these are all things we can use to build better solutions for the future. So from an immediate perspective, just embrace the fact that this is a philosophy. I'm not talking about a set of requirements, but something you can change the philosophy of how you approach building. And then, try to find some products some new things that you're building to apply this to, and then start to figure out how to reverse engineer these steps onto things you've already built and try to make incremental improvements to those things as we go. So yeah, it's a philosophy and a journey. The decisions do drive our high-level design conditions. The patterns help us to identify those paved roads, those things we want to make repeatable. Threat modeling helps us to check the work and to get to this future where we've really started to implement these things. It just requires us to start today, because we've been sitting on this for a long time. We have an opportunity now to change the things that are the core of our applications in 1, 2, 5, 10 years into the future. So with that, this is a couple of ways to contact me. If you're interested in threat modeling, the Devici and I are up in the early stage expo in the South Hall 208. So if you want to stop by and see what we're up to. There's my contact information. I do a bunch of podcasts. I've got a newsletter I put out on the AppSec front as well. With that, love to take any questions anybody might have, or opinions, or anybody wants to tell me that I was wrong about different things. But yeah, please go to the microphone if you want to ask a question or share an opinion. We'll go over here first. Yes, please. Right here.
Yeah. So, if I summarize what I've taken away from your this presentation, right? Basically, to me, it seems like you're talking about one security fits all. Like if we have this, we follow all of these practices, it should fit all. You said you have been in this security industry for a long time. I've been in it as an individual contributor and middle management and leadership roles for some years as well. In my experience, I haven't seen that one security fits all has ever worked. So I would like to know your perspective on that. So as you said, at philosophy level, yes, it sounds very solid. But when I try to fit it into what I have seen working, at least to me, it doesn't. So do you have any counter examples for that?
I mean, I think as I said, depending on what you're building, depending on what your company does, the design decisions may be slightly different or slightly modified from what we're describing there. But I think the idea of building on top of a solid stack, the different things that we described there, I think are, I think they are universal from my perspective. And I've had a chance to be inside of Cisco for 11 years, where we had thousands of products, from metal boxes to cloud services and everything in between. And I think you may have to adjust those design decisions. I'm not saying that these are the things that are set in stone, like these are the only ones you can do. But I think the concepts are solid, and then I think the patterns, we've been clamoring for those type of patterns to be something that can be applied to various types of products as long as I've been building things. And so I think these concepts are more universal. I think that's just kind of where I land on the decision. But thank you for your question. And maybe I'll catch you after just to hear examples of what you've seen that you think it wouldn't work with. But we'll end right here. I think we got time for one more.
Thanks, Chris, for all the information you took us from a concept all the way to threat modeling. I wonder, as a new company, or as a new product, how do you know you're secure enough or private enough before you go to market? And then the other question is, when you choose your single sign-on providers or applications and MFA, what's your process, or how do you choose your technology stack for that?
Yeah, I mean, I think for new companies, for building something new, I guess my big wisdom would be the more of this you do up front, the less trouble you're going to find yourselves in when you try to sell to a large enterprise, specifically in the financial sector, perhaps, where they're going to have a very stringent set of requirements, even for the smallest startups, to have to apply. Right? And so I think that's some of the balance, though, in applying and doing this from as a small company where you don't have unlimited resources. I landed on AWS's Cognito because we were building on top of AWS's stack. And so I think some of that comes down to, the good thing is there's so much parity now in like cloud providers. There's very little innovation at the individual service level. So no matter what cloud you're using, there is a Cognito equivalent in their world. And so I think that's also a very big positive, because if you're a startup building something, you don't have to spend a lot of time worrying about SSO. You can just integrate their approach, now they do have some stringent rules on how it works, but that's worth the trade-off of trying to create something from scratch. So I think but that's a great question. I mean, you build this stuff from the beginning, you're going to have an advantage as we go further into the future as these things become, they're a big deal now, they're only going to get bigger. People aren't going to relax these types of requirements. So. All right, thank you very much, everybody. Thanks for being here. Have a great rest of your conference.